Good evening. So today is the day 6 of our daily physics practice program, right? So far we have completed 5 questions, right? So slow and steady. Let's start, the practice of physics questions, right? So it won't be only based on mechanics, right? So it will be based on, other lessons also. So generally from the, start off, right? To start off, I have chosen mechanics because mechanics is the basic, the foundation. So from mechanics, we'll be going on to waves, heat, right? So it will be going on, right? So so today is also a mechanics type question, right? So this today is the day 6 of our program, and it's the question number 6, right? Okay, so this is a Royal College paper, right? So first of all, the three aspects, right? So how we can do a question. First, we should read the question properly. Second, we should analyze the data they have given. We should arrange them. And third, we should know, or we should analyze by reading. We should analyze what are the laws we can apply, what are the equations we can apply, and what are the theory content, right? Okay, let's read it first. The diagram shows smoke of density rho rising vertically from a furnace through a small tall chimney. Point B is at a very vertical height h above point A. The cross-sectional area of B is three-fourths the area of A. If smoke particles move continuously, streamlined and without viscous forces, and if at A the speed is V and pressure is P, what is the correct expression of pressure at B? Are they asking what is the pressure at B, right? Okay, so so this is a, I feel it's a hydrodynamics type of question, right? So the concept we can apply here is the hydrodynamics, right? So hydrodynamics is the concept they are applying here, because if you see here, normally there is pressure involved, volume is the velocity is involved, surface area is involved, right? The cross sectional area is involved, velocity, pressure, and they have said there is no viscous force, which means that it is not related to properties of matter, viscosity or something like that, right? So they have mentioned streamline, continuous, so it is a hydrodynamics type of question, right? So let's see. So they have said that there's a smoke that is going through this part, right, through this chimney, and at this point at A, the pressure is P, it seems, the velocity is V, it seems, and the cross sectional area, if you see, the cross sectional area is A, right? So if you see here, the cross sectional area has reduced, so it is 3 for the area of uh, the A part, right? So when you see area is given, velocity is given, so we know the velocity at point A, we should know the velocity at point B, right? So let's mark it as VB. So if we want to find VB using the areas, the only equation we can apply is equation of continuity, right? So I'll use another color, right? Right. Right. Wait a minute. Right. Equation of continuity. According to equation of continuity, A1 V1 equal to A2 V2, which means the cross-sectional area, the first initial cross-sectional area and the product of it with velocity would be equal to the cross-sectional area and the volume, which means now area into velocity means volume flow rate. Area into velocity means volume flow rate. So they are saying what are all the components that are flowing through this will be flowing through this, correct, right? Now just think there is a bucket, something like this, right? Right? So there's a tap, something they have connected like this. All what we pour here, it will be flowing through this, right? So we can say that the volume inflow rate and the volume outflow rate are equal. So they have given that in this aspect, right? Area into velocity is equal to volume flow rate. We have discussed close related question before this question. I guess it was question number 4, something like that. So we have discussed about this, right? If you can't remember, you can watch that recording also, right? Okay, so here what we will do is we'll use the the values they have given here, right? So area, they have said that A, it is A. The velocity they have said as V, right? Area 2, second area is 3 over 4th of A, 3 over 4th of A. velocity, second velocity, which means velocity at B. We have to find this in terms of these, right? So if we find, it will be VB equals to 4V over 3V. Why? A and A would be cutting off, right? Okay, we have found the velocity of V with respect to the velocity of A, right? Okay, so if area is larger here, velocity is lower, right? That should be understood. If area is higher, velocity would be lower according to the equation of continuity. So the second law we can apply here is Bernoulli's principle, right? Bernoulli's, no, this is a simple question. Bernoulli's principle, right? According to Bernoulli's principle, we know that pressure plus half rho v square plus rho gh is a constant. This is the Bernoulli's principle, right? This is applied to non-viscous streamlined flows, right? Compressible flows, right? Okay. Now what we can do is, let's see and manage, right? How we can arrange these information into that equation, right? Okay. Now we know the pressure at A is, they have given it as P naught. I guess, yeah, they have given us P. I hope this should be P naught, right? So this should be P naught because in the answer they have given it as P naught here, right? So I have P naught. It is P naught, right? Fine. So we have to find the pressure at this point. That is the question, right? That is the question. So we can understand that here there is a pressure and velocity is present, which means there is a kinetic energy, but here there is no any potential energy. That should be clear, right? There is no potential energy per volume here, right? Which means here we can, you know, we can take this point at A, and we can mark that GPUE equals to 0, which means from here onwards, all the measurements, height measurements, all are gravitational potential energy measurements are taken as positive. Below this will be negative, which means just think like this. Now, if there is a flow in this direction and if there is a height, we will be taking this height as negative height. Why? Because it is below the point we have chosen. But after the calculation, when we are going through the calculation, trust me, it will be becoming, the values will be cancelling off and it will be positive. If we take it as this negative, which is below the GPE line, right? It will be, when we are doing the question, it will be generally, it will be becoming positive, right? Okay. So here what we can do is, we have taken this point. So we'll apply for the A part, right? Okay. So pressure at A is P naught half rho, velocity is v square, and there is no gh, right? Equals to P at B plus half rho, velocity at B is 4v over 3. So 4v over 3 complete thing square plus rho gh. You might ask, so where is this rho gh? Here see, there is a h. So there, from this there is a height, which means there is a potential energy per volume, right? Is that clear? So that is the potential energy per volume, right? So if you find difficulty in understanding the Bernoulli's principle, it is simple, right? Now we know that Bernoulli's principle, it speaks about energy and the pressure, right? If you see here, this rho gh eventually came because they have considered this as, this pressure is pressure per volume, right? This is kinetic energy per volume because this rho came by dividing the mass by v, right? So this rho g came because mgh, right? It is divided by v, right? Okay, so what we can do, p naught plus half rho v square equals pb plus half rho 16v square divided by 9 plus rho gh, right? So we can take all things, all the components except for pb onto the other side, right? Right. So let's take all the pressures except for PB onto that side. So PB equals P naught plus half rho V square minus half rho 16V square divided by 9. This plus, if you take this side, it will be minus rho GH. So we can see that for all these except for P naught, rho is common. So let's take that rho out because that's a bit confusing, right? So PB equals P naught plus, right? Plus, let's, there's plus here, right? So let's mark it as plus. We should do this carefully because we know the concept. Here, a student can make mistake when, doing the calculation. So we should be very, very clear here. Very, very careful here, right? Okay, let's take rho out. So it will be V square divide by 2, right? Minus half 16 V square divide by 9, right? Minus rho GH. Now rho GH we can, for the time being we can neglect because there's a, some sort of a competition between this V square. We have to cancel this off because here there's V square, here there's V square, right? What we can do here is we should multiply this by 9, right? We can multiply this by 9 so that we can produce here 18. So the denominator will be same, right? See here, PB equals P naught plus rho. If I multiply this section by 9, it will be 9V square divided by 18 minus, this will be completely 16V square divided by 18 minus rho GH. I hope that's clear, right? So if I subtract, this is a small number, this is a large number. So eventually it will be a negative 1. Let's see. PB equals to P naught plus rho minus, now 9 plus 9 minus 16 is minus 7. So minus 7V square divided by 18, right? Here it will be, now you see, this is minus, right? These should have been cancelled off, right? This will be completely calculated. So it will be minus rho GH, right? So if I now if I take this out, which means the row part, it will be looking like this. Why? Now see, just check whether it is clear. P naught minus, because plus into minus is minus rho 17 v square over 18 minus into plus minus rho gh. Sorry, wait, sorry. A small mistake here. Why? Because I have taken row here, so here row cannot be considered because row will be out. Here also same, right? Here also same, and yeah, here it's fine, right? Okay, so it will be rho gh. So rather than keeping a complex part, if you see in the question, let's see how in the question they have taken. So in the question they have taken the row part out, so let's do it as like that. So if we take the row part out, it will be looking like pb equals to P naught minus rho or 17 V square minus, sorry, not 17, here it's 7 right here. It's my mistake because, while writing it, there's been a small mistake with it. Thank God, without making a huge mistake. Right? 7, right? Sorry. 7V square, 7V square, right here, 7V square, and then it's 7V square over 18 minus rho g h. So rho will be out, right? This rho will be out. Why? Because the rho has been taken out, right? We should be careful here without making any mistakes, right? Right. Done. Right. Question has been done. Right. Okay. So PB equals P naught minus rho 17 V square minus GH. Let's see, do we have any answer like that? Wait, I'll check it by like this, right? I hope it will be right. The answer is P naught minus P rho 70. The first one is wrong because there is no minus. Second one 16, no 16. It's not 16. Third one is also wrong. Fourth one seems correct, right? Fourth one seems correct. Let's take the fifth one also. Fifth one is wrong because plus GH, right? If you see fourth one and fifth one, small mistake with respect to the plus and minus, right? So if we consider, answer is fourth one, right? I hope it's clear. As some sort of work, right? If you do it patiently and carefully, we can get the answer, right? This is the method how we can do it, right? Okay, then that's the sixth question, and it is day six, and the sixth question, which was on hydrodynamics, right? I hope it was clear and it was useful for you all. So hope you to meet on day seven for the question number seven, right? So work hard and keep this practice of questions, right? The questions will be on flow, and we'll be discussing through YouTube. The questions will be uploaded, the workings, the explanations will be uploaded in the YouTube, right? Okay, then goodbye.